Today's topic is recursive routines. Now, the word recursive means to happen again and again and again. And a routine is how we're going to explain what's happening again and again. So an example of a recursive routine might be 2, and then the next might be 4, and then 8, and then 16, 32, and then moving on and on like this. So here, specifically, our recursive routines are going to depend on multiplying by some number. Here, each time we're multiplying by 2, so doubling each term. Multiplying by 2 each time here. So here, this 2, we're going to refer as the multiplier. Now, maybe I should have started with a better value, but here, this term right here, my first term in the sequence is going to be like this. So here's a sequence of numbers where we have 2, 4, 8, 16, 32 being continued, ... by multiplying by 2 each time. This would be called my first term. A lot of times we might call this terms like a sub 1 might be my first term, and then I could say a sub 2, meaning my second term, a sub 3 would be my third term, and then continuing on like this. Probably better might even be using a sub 0 to be the initial term. This would probably be better described as an initial term. And then from here, this initial term, we might move to the first term, and then the second term, and the third term, and moving on. Sub 0 is nice. When we use 0, that would mean initial or the start value. So a few ways to look at this. So it can be written either way, as this being my a sub 1, but it might be better as saying a sub 0, meaning an initial term. Actually, we'll probably use this value for my initial or start value more often, just because it works nicely in our explicit equations that we'll talk about later. So to write this recursive routine, we can look at it like this. To write a recursive routine, here our recursive routines are going to be based on multiplication. So multiplication. So I might start my first term for this particular recursive routine that we have here. I'm going to start my initial term at 2. So I'm going to use a sub 0 here, and most often we will. Then you can recognize that each term depends on the term right before it. If you remember using this when we talked about lines, here we use one term and then the term right before it. So if this term is a sub 3, this term would be 3 minus 2. This would be a sub 2. Or if this term is a sub 7, this would be 7 minus 1. This would be a sub 6, the number right before it. Here, and then, so what we have here is any term depends on the number right before it. Like to find 16, we need to know the number right before it, but each time we need to multiply by 2. So to find 8, if we wanted to find this term, I need to know the term right before it, 4, and then I multiply by 2. So here, I can state my first term, my initial term would be 2, and then every time to get to the next term, if I want to get to this next term here, if I want to get from this term to the next term, I'm going to multiply by 2. So I go to 4. If I want to get from this term to the next term, I'm going to multiply by 2 again and get 8. So here we can see it multiplies, and then we wind up with the same recursive routine we just described. Let's look at another one. Let me start my initial term at 3 this time. And here I could write it to get to each term. Any term depends on the term immediately before it, but this time I'm going to multiply by, let's do 1/2. So here we should see our sequence should be going down. So I'll start at a 3 at my start term, then I have to multiply by 1/2. So this should give me 1.5. To get to the next term in the sequence, I have to know the term right before it. Here I know the term right before it. To get to the next term, which is a sub n, I need to know the term right before it, the n minus 1, and I'm going to multiply by 1/2. So getting to 0.75. And then to get to the next term, I'm going to multiply by 1/2 yet again. Yielding what, 0.375, and continuing on and on like this. So this is what's called a recursive routine. And this a sub n minus 1 and a sub n really determines what this is talking about. This would be my a sub n minus 1 if this is this term right here. This term right here is a sub n, knowing the term right before it. Because here, if this is a sub 0, this is a sub 1, this is a sub 2, this is a sub 3, a sub n meaning a generic term, and a sub n minus 1, 2 minus 1 would be the term right before it. So this means that it's the term right before. So to find a term, to find any given term, I need the term right before, and I multiply by 1/2. So if I wanted to find this term, I need to know the term right before, and then I multiply by 1/2. This is the essence of what's called a recursive routine. Here is what's recurring. This is the multiplier. And here, we'll call this the initial value. And I'll set up some example problems for us to work on later.